Hi, welcome back. We are continuing in Chapter 10 today with data analysis and statistics, but today we're looking at section 10.3, which is continuing how we display data. I'm hoping we have a quick little video for you here today to talk about line graphs, scatter plots, the relationship between a pair of variables using a scatter plot, trends lines, positive and negative associations, and choosing how to display data. All right, so a line graph typically shows trends in a variable over time. Time is typically marked on the horizontal axis, and the variable is that's being considered is marked on the vertical axis, and consecutive data points are connected by line segments. So, for example, we might want to look at a child and their growth in their weight over 10 years of their life. This is continuous data because from year to year, her weight didn't just spontaneously jump from 5 pounds to 19 pounds. Over the course of that year, she was growing, so we connect it with a line. So her age is on the x-axis and her weight is on the y-axis. All the other data we've seen so far have been considered discrete, meaning that we can't necessarily draw these lines between them. Something I want to bring your attention to while we talk about representing data is that we need to pay attention to the scales that we choose to use to represent our data. We could plot the number of graduates at a certain community college by year. These data range from 140 graduates to 210 graduates, and but these two charts actually give the exact same information, but they don't convey the same psychological message, right? Here it looks like the number of community college graduates has been roughly the same over the past 5 years. However, here, this shows us that there's been a steep increase and then a steep decline because we chose a different scale on our y-axis. So just be careful when you're interpreting data that you pay attention to what scale it's being used. So sometimes a relationship between variables can't be depicted by even a broken line, so we have to use a scatter plot instead. So a scatter plot shows a relationship between two variables. In this case, in this example, we have the number of hours studied and the quiz scores that were received. So the highest score was a 1, and the highest score is a 10, and the lowest was a 1. So we can look at each of these data points and interpret something about them. So here, this data point tells us that a student studied for 7 hours and they got a quiz score of 5. So each of these data points tell us a number of hours and the score received. We can add what's called a trend line to scatter plots to understand patterns in our data. A trend line is a line that closely fits the data to describe it, and we can use trend lines to make predictions. Now we have to be careful making extrapolating predictions because in this case the highest score that we can get on a quiz is 10. So even though this trend line appears to be increasing, that doesn't mean that if we study 100 hours that we can get a 50 on the quiz. The maximum quiz score was a 10. So there are bounds to this prediction. There are associations that we can observe with trend lines. So if the trend line slopes up from left to right, then we call that a positive association in the data on the horizontal and the vertical axis. That means that an increase in the value on the horizontal axis would predict that there's an increase of the variable on the vertical axis. So for the studying and quiz test or quiz scores example, we would see that we might predict the more you study, the higher quiz score you are going to get. We also can see negative associations. So if the trend line slopes down from left to right, then we say that there's a negative association. So an increase in the horizontal axis would predict a decrease in the vertical axis value. There's also a case where we might see no association between the variables. So we have kind of just a weird, vague cloud of points here. We might say in this case that there's no association and we can't really make a prediction of one value based on the other. Another way we can represent data to compare them, two sets of data, is with a multiple line graph. So for example, we might want to know about the crowdedness of housing between 1940 and 2000. One line shows crowded being defined as more than one person per room, and the other shows severely crowded with 1.5 persons per room. So we can compare how those trends have changed. Choosing the right display of data isn't always easy, and there might be more than one appropriate choice. So let's just go over the visual displays of data we've talked about so far. So a pictograph is used to show data with pictures or symbols. A dot plot is used often to show frequencies. Stem and leaf plot shows us each value in a data set and helps us group values into intervals. A bar graph is used to compare numbers of data items in grouped categories. A histogram is working with numerical data, and it helps us compare numbers of data items in certain intervals. A circle graph shows the division of a whole into parts. Again, that's categorical data. A percentage bar shows the division of a whole into parts. So it's like a circle graph, except for it's just going to be a vertical bar split into categories with a max 100%. Then a line graph is used to show how how data values change over time, typically for continuous data. And then last but not least, a scatter plot shows relationship that happens between two variables. And that is all for this lesson. Get ready for a bit longer video next time, but I hope that this helps, and let me know if you have any questions. Have a great day.